marketing Ethereum in December. I had £500 left. My rent was £500 a month. At that point, I've done 2 startups. Neither of them seem to be doing anything. I'm just going to get a job at a bank. And then he offered me £1,000 a month to just carry on doing Ethereum. I wanted to see if this white paper could work, so I started coding it. A few months later, I was the co-founder of Ethereum.
When Ethereum co-founder Gavin Wood sat down for a revealing interview about the future of the platform he helped create, few expected the brutal honesty that followed. With just £500 to his name in 2013, Wood helped build what would become a $1 trillion ecosystem. But his recent revelations paint a startling picture of Ethereum's future. If you'd asked me 10 years ago what success would look like, today's reality wouldn't match those expectations, Wood admits candidly. This shocking admission from one of Ethereum's architects suggests something profound about the platform's direction. The hard truth: Ethereum's greatest achievement so far isn't technical innovation, it's wealth creation. Ethereum made the most millionaires of any project in the history of the world, Wood notes, but his tone suggests this isn't cause for celebration. Wood exposes 3 critical technical challenges facing Ethereum. Ethereum's scalability challenge extends beyond simple transaction throughput. The fundamental architecture faces limitations in processing complex smart contracts and decentralized applications at scale. Current solutions like Layer 2 protocols provide temporary relief, but don't address core architectural constraints. Sharding, initially seen as a promising solution, introduces new complications. While it allows parallel processing by dividing the network into smaller segments, it creates synchronization challenges between shards. As Wood points out, this fragmentation complicates cross-shard communication and transaction processing, potentially undermining the network's efficiency. Synchronous composability represents perhaps the most complex challenge. Different smart contracts and protocols need to interact seamlessly in real time, similar to how traditional applications work. However, sharding makes this difficult since contracts on different shards can't directly interact without additional overhead. This threatens Ethereum's ability to support complex DeFi applications and other interconnected systems that require instant atomic transactions across multiple protocols. The convergence of AI and blockchain technology presents a transformative moment for Ethereum. Wood's warning about AI's role in human communication reflects deeper implications for decentralized systems. As AI becomes more sophisticated, it could serve as an intermediary layer between humans and blockchain networks, potentially enhancing user experience, but also introducing new centralization risks. Smart contracts powered by AI could enable more sophisticated automation, self-optimizing protocols, and adaptive systems that respond to market conditions in real time. However, this integration raises critical questions about control and transparency. AI systems might become powerful enough to manipulate blockchain networks in unexpected ways. Privacy concerns intensify as AI's pattern recognition capabilities grow stronger. The combination of blockchain's permanent record-keeping and AI's analytical power could compromise user anonymity. Security also faces new challenges, as AI could be used both to defend against and execute sophisticated attacks on blockchain networks. Wood's current work on the Jam project suggests a radical rethinking of blockchain architecture. He describes it as an agile way of bringing together different people in the playgrounds, a technical metaphor that hints at a completely new approach to blockchain scaling. It takes time for people to grasp a technology that fundamentally changes how we trust each other without knowing each other, Wood explains. He suggests adoption could take anywhere from 5 to 50 years, a time frame that might shock investors focused on short-term gains. Wood highlights 4 critical developments addressing Ethereum's limitations. First, new transaction processing methods aim to handle complex operations more efficiently, moving beyond simple token transfers to support sophisticated smart contract interactions. Alternative scaling approaches look beyond traditional sharding, focusing on solutions that maintain network cohesion while improving throughput. Wood's Project Jam represents one such approach. offering dynamic partitioning rather than static sharding. Novel consensus mechanisms explore ways to achieve network agreement more efficiently than current proof-of-stake systems. These mechanisms aim to balance security, decentralization, and scalability more effectively. Cross-chain communication protocols focus on seamless interaction between different blockchain networks. Rather than isolated systems, these protocols enable fluid data and value transfer across chains, supporting a more interconnected blockchain ecosystem. Wood emphasizes that these developments must maintain decentralization while enabling greater scalability and functionality. Wood uses Sweden's payment system vulnerabilities to illustrate why decentralization matters. The country's centralized payment infrastructure has proven susceptible to cyber attacks, causing system-wide failures that affect millions of users simultaneously. This real-world example demonstrates how centralized systems create single points of failure that adversaries can target effectively. In contrast, decentralized systems distribute risk and control across multiple nodes, making them more resilient to attacks. Even if some nodes are compromised, the overall system can continue functioning, providing greater stability and security for critical financial infrastructure. We're not just building technology, Wood emphasizes. We're laying the groundwork for a fundamental transformation in how humanity interacts with the digital world. Better user interfaces need to make blockchain interactions as simple as traditional apps, hiding technical complexity while maintaining transparency and control. This means intuitive wallets, straightforward smart contract interactions, and clear transaction processes. Improved scalability solutions must handle millions of transactions while keeping costs low. The goal is matching traditional payment system speeds without sacrificing decentralization. Enhanced security measures protect against both traditional and quantum computing threats, while making security features more user-friendly. Seamless integration with existing systems enables blockchain technology to work smoothly with current financial infrastructure, business systems, and everyday applications without disrupting established workflows. Wood's insights force a fundamental rethinking of Ethereum's timeline. Investors expecting quick returns may need to adopt a much longer perspective, potentially spanning decades rather than years. As he notes, true adoption could take 5 years or 50 years. For developers, this means prioritizing robust, foundational solutions over temporary patches. Rather than building quick fixes for immediate problems, the focus must shift to creating sustainable infrastructure that can support long-term growth and adoption. The platform's evolution may diverge significantly from current expectations. Wood's work on alternative solutions like Jam suggests Ethereum's future architecture could look radically different from today's design. Most critically, AI integration could completely reshape Ethereum's development path. The convergence of AI and blockchain technology might create entirely new use cases and challenges, potentially transforming Ethereum from a smart contract platform into something far more complex and sophisticated. Wood's original Web3 concept emphasizes 4 critical elements that remain relevant today. True decentralization goes beyond just distributed networks. It means eliminating single points of control and ensuring no entity can dominate the system. User privacy has become increasingly crucial as data exploitation grows. Wood envisions systems where users control their data without sacrificing functionality or convenience. Scalable solutions must support mass adoption while maintaining decentralization. This means moving beyond current technical limitations to handle millions of users and transactions efficiently. Practical utility focuses on real-world applications beyond speculation. Wood emphasizes creating systems that solve genuine problems and provide tangible benefits to users, moving past the current focus on trading and financial speculation to enable meaningful decentralized applications. The path forward outlines a vision for blockchain technology's evolution through Wood's project initiatives. The integration of solutions like Jam points to blockchain networks becoming more energy efficient and cost-effective through improved consensus mechanisms and scalability solutions. The focus on interoperability suggests a future where different blockchain networks can communicate and transfer assets seamlessly, breaking down existing silos. The convergence of AI and blockchain technologies opens possibilities for decentralized AI applications, automated smart contracts, and more intelligent network operations. These developments, combined with simplified interfaces and improved transaction speeds, aim to make blockchain technology more accessible and practical for everyday users, moving beyond its current technical barriers. Wood's analysis reveals deeper complexities in Ethereum's development trajectory. The technical hurdles facing the network, like scalability and energy efficiency, appear more deeply rooted in the blockchain's fundamental architecture than previously thought. This suggests that incremental improvements may be insufficient, potentially requiring radical new technological approaches or complete redesigns of core components. These fundamental challenges could extend the timeline for mainstream adoption beyond current market expectations. The integration of AI technologies emerges as a critical factor in addressing these issues, potentially enabling more efficient network operations, improved security mechanisms, and automated optimization of smart contracts and network resources.
So Ethereum in 2032, you have a node. Your node runs on your phone. Every 12 seconds or 32 seconds or whatever number we agree on, you download 3.6 megabytes of data, you hash it, you do a couple of elliptic curve equations to check a snark. That's it. You know the block is valid. Wait 12 seconds, get 3.6 megabytes of data, hash it, do some elliptic curve operations, verify the snark, and valid. 12 seconds later, data, hash, elliptic curve check, valid. The whole process just becomes incredibly sleek and seamless to the point where like literally a phone could even do it, right? Because it's incredibly light on computation. The only thing that it's heavy on is data, and data just happens to be the thing that, phones are increasingly getting insanely good at and will get even better at over the next 10 years. That to me is what I see the final goal being from a protocol standpoint.
The future of Ethereum depends on solving these fundamental challenges while maintaining the original vision of a decentralized digital world. The platform stands at a crucial juncture, with its future success hanging on the ability to adapt and evolve. What's next? According to Wood's latest insights, the next phase of Ethereum's evolution will focus on fundamental technical improvements, better integration with emerging technologies, enhanced scalability solutions, improved user experience. These changes could reshape Ethereum in ways few currently imagine, suggesting both challenges and opportunities ahead for developers, investors, and users alike.